educator, also at the Collaborative Learning Center. I'm a senior studying human biology, and so we're going to go over some tips today that will help you learn how to study for math and different techniques to approach different types of math problems. Okay, so just as an exercise to start, obviously usually these workshops are in person, but we're recording them given the circumstances, and so hopefully you'll be able to participate as much as possible. So if you see an activity where it asks you to think about something or write something down, please pause your video and take a few seconds to talk about it, or just think about it on your own. So the first one says, name the Great Lakes. So off the top of your head, can you name the Great Lakes? Can you think of how many they are? Can you think of what letter they start with? Is there a way that you usually use to remember them? Just take a minute and think about that. Okay, so then looking at them, there's Lake Huron, Ontario, Michigan, Erie, and Superior. And this is something that I actually learned back in elementary school, but the first letter of all of the names of the lakes spells homes going down. And that's just kind of one little trick that you can use to help remember things. And it may not necessarily pertain to math right now, but you can use it to help remember different rules. We all know like PEMDAS, like parentheses, exponents, multiplication, division, addition, subtraction, things like that. So you can always make these devices up as you go to help you remember information. Okay, so now we're going to talk a little bit about long-term retention. So this is Ebbinghaus's forgetting curve, and basically this is showing you how much information you forget if you don't review the information. So you walk out of lecture, you think you know everything about what the professor just said, you understand 100% of the information, and then you choose not to look at your lecture, you just go about your day. And after just 20 minutes, you've already forgotten about 40% of the information and you're only retaining about 60%. If you don't look at the information for a whole day, now you're down to like 35%, and that amount just keeps decreasing until after about a month, you only know about 24% of the information. So it's really important that not only are you paying attention in lectures, but you're also refreshing this information in your mind frequently so that you can retain the information for longer and be able to perform well on exams and finals. And so spaced repetition eases the forgetting curve. So it decreases the rate at which you forget. So this first one in the top left corner over here is all showing you what we just showed you. After about one day, you're forgetting a ton of information. But if you review it once, that curve gets a little bit less steep, and twice, and the curve gets even less steep. And if you keep reviewing it, pretty soon all of that information will be transferred to your long-term memory. And by the time you get to the exam or you get to the cumulative final, you already know most of the information and you just need to brush up on the details. And this is really important for math because the information usually builds on each other. There's not distinct units, and you can't just forget what happened in the last exam if you want to learn how to use it going forward. And you're also going to need it if you're taking a math class. You might need it for your major, you might need it down the line, you might need it in the workforce. Okay, so this is just one way you can kind of start to structure your time. You can set out specific times every day to study for specific classes, and it doesn't have to be that long. There's like hour and a half chunks in here, but it kind of breaks it up in the morning, afternoon, and evening. So if you know you have a lot of time on Thursday mornings, maybe that's when you should schedule your time to study your math. Or if you can take 15 minutes after your lecture every day to kind of review it. Or if you can make it a plan to get to class 20 minutes early, get a really good seat, start studying then. And then just prepare for your lecture before the lecture actually starts. That's a good way to practice space study as well. So after reviewing the information from the most recent class, make sure you're going back and studying the older information to keep it fresh. So you should start with the most recent. What did I learn just now? What did I learn yesterday? What was my homework just on? And after you get that cemented in your head, then you can move even farther back and review things from one day ago, week ago, a month ago, and from the class in general. So it's just really important to keep going back, and although it may seem like more work at first, it definitely saves you time in the long run because you don't have to keep relearning the information into your short-term memory. So this is kind of a demonstration of what happens if you space your study out. So if you're Nora and you decide you're going to study for 4 hours the night before the exam, chances are you're going to be tired, you're going to be crabby, you're just trying to cram all the information in your brain, you're not doing homework for any of your other classes, you're not eating well, you're not sleeping, and you probably aren't going to do super well on the exam the next day. You might pass it, you might be okay, but you're not going to get the grade that you want or the best grade that you can accomplish. Then if you're Leanne and you're like, okay, I'm going to start a couple days before the exam and I'll study an hour every day. Well, that's a little bit better. But what's best is to split it up as much as you can. So if you can think, a week out, if I just review my information for a half hour every day, and I've been doing this spaced practice throughout the semester in like 15-minute chunks, then you won't have to go and study so hard. You can just study more frequently, and that will help you to remember, oh, this is how I solve this math problem. This is how I, approach these problems. This is the technique I should use. And you can help, it also helps you to combine all of the different topics. So tips for studying math in particular. Okay, the first tip is to discuss it. So, whether that's with a friend or call up your mom, be like, hey mom, I'm gonna talk about my math lecture or anything, or even just talking to yourself out loud. Summarize your most recent lecture from memory. What did we learn about? What were the 3 main techniques we used? What was hard about it? What are the important points? What are the material do I understand well? And what material still confuses me? And if you get into the habit of doing this at least once a week, that's a really good time for you then to go to your TA or ULA's office hours and be like, hi, I'm really confused on this part, rather than it being 8 p.m. the night before your exam and you have no idea how to approach a problem. It can be as simple as just 2 minutes running through it, looking over your notes and thinking about it, but it's enough to get your brain working. And even if you go eat lunch afterwards or something like that, your brain's working memory is still going to try to encode that information. Tip number 2, be the teacher. So work your problems as if you're responsible for explaining the problem to the class. So if you're having trouble remembering how to do something, see if you have a friend that is also struggling with the same information that you are and ask, hey, can I explain this to you? Or make sure you write out really clear and answers that you can follow all the way down the page, so that if you needed to turn around and explain it to someone, you could. And if you get stuck, then that tells you where you need to go back and start over and relearn the information, because if you can't teach it, you don't understand it well enough for the exam. Okay. Compare and contrast. So some problems may be similar, but require some different techniques. So finding a slope of a line passing through the point 2, 1 and 3, 4, and then finding the slope of a line given by the equation 5x plus 2y equals 16. Probably going to come out of the same chapter of the textbook, might even come out of the same lecture, but the way you approach them are a little bit different. And if you don't know similarities and differences between those two, you might get stuck. On the same note, a problem may be solved using various techniques. So if you're trying to find the equation of the line passing through that point, those points, there might be different ways to approach it, and kind of having an ordered list in your head. Which way do I prefer? Which way is best if they already give me the y-intercept? Which way is best if it's in standard form? Which way do I like the best versus which way does my professor focus on? That way you're prepared for anything and you're ready to solve any kind of problem your professor could give you on an exam. Okay, tip 4, practice retrieving information. So this is all about not just passively reading. So if you're just looking at your math notes and you're like, okay, I know how to do that, you're not actually learning how to retrieve the information from your brain. You're just convincing yourself that you know how to do it. So instead, what you should be doing is saying, okay, I'm going to read this problem from my notes, so I'm not going to look at how I solved it. I'm going to write down how I think I should solve it. I'm going to think through step by step how to solve it, or I'm going to teach this to someone else. And then I'll check my answers in my notes and see if I was right. Okay, now we're going to talk a little bit about making flashcards for math. Okay, so what should you put in a card? So here's where we usually pause and have people talk about how they usually make their flashcards. Do they use them? Do they use Quizlet or something with the pre-made card? What type of information are you putting on it? If you just want to take a minute and think about your current study habits with flashcards, please do that now. Okay. So there's different ways you can approach it. So if you're trying to find the x-intercept of an equation, and then you can write on the back set y equal to 0 and solve the equation for x. This is a very simple flashcard, obviously, but you can just make them tailored to what you need to remember. If you're having trouble finding or remembering the steps to solve a problem, you can go ahead and write that out on a flashcard. If you're having trouble remembering simple rules, you can write the rules out. If there's specific problems that you want to keep working through to get the habit down or following the correct process, that's also something you can add to the flashcards. Okay, so some tips. Making your own cards is super helpful, especially for math, because so much of math is writing out the problem and getting through the problem, and just writing it out on the card, even if you're kind of copying it from your notes, but thinking about, okay, this is how I do it while you're making the cards is one extra chance to retrieve the information and practice repetition. Mix words, so if there's graphs or pictures or any drawings you can include, especially for word problems and things like that, those are really important to put on there. Say your answers out loud when studying. This helps you to avoid being like, oh, I know that, I'm going to go to the next one. No, you have to say it. If I got it right, it goes in one pile. Got it wrong, it goes in the other pile, which we'll talk about later. Studying your cards in both directions. So while it's really great to read a definition and know what the word is on the other side, you really have to make sure that you're able to recite the definition from the word too, for it to be effective, because if you get a fill in the blank, you might be okay, but if you get a short answer question, you need to be able to come up with a similar definition on your own. And then study your cards frequently. So this is a little kind of animation to show you how to study the flashcards if you have a lot of time before a test. So if you're making these after every lecture or every week, this is a really good way to make sure that you're reviewing them and using space practice. So you study this, identify the domain and range of a function. You're studying it every day. You get it right, you move it to the every other day pile. And now you have a new card in the everyday pile. Create a table and graph of a function, even in symbols or in words. And so I'm going to study that every day, and that's going to go in the every other day pile too. So now I keep going, and every time I get it right, I move it into the every other day pile. Now the next day comes along, and now I'm going to do my everyday pile and my every other day pile. And if I get it right, I'm going to move it to the once a week pile. And if I get it wrong, it goes back in the everyday pile because obviously I forgot it, or it's just something I need to review more. And you can keep going with this until you get all of your cards through to the review before the test, and then the day before, a couple days before the test, you can just calmly go through your flashcards and you'll know all of the definitions. Okay, tip 5, switch between focused learning and diffuse learning. So there are two ways of thinking, and one is really focused, and where you sit down and you use focus to do a specific task. You're concentrated, you're determined, you're like, okay, I'm going to solve this problem, I know how to solve it. These are the steps I'm going to take, A, B, C, D, and then this is the answer. And then there's diffuse learning, and this is more relaxed. This is like, oh, I haven't really seen this kind of problem before, but before I look at the answer key, I'm going to think about it. I'm going to let my mind kind of wander. And both of these are really important because you need to be able to think on your feet during an exam. If a professor kind of throws a curveball at you, or if you happen to not study a specific problem that happens to show up on an exam, it's really important to be able to like cognitively think your way around the problem rather than relying on like the regimented routine that a lot of us math is. Okay, so the next step is interleaving, and this is way to study where you practice by doing a mixture of different kinds of problems that require different techniques. So if you have 4 chapters of information on your exam, you shouldn't just study all chapter 1 one day, all chapter 2 the next day. You really want to mix them up because that's the way you're going to see it on an exam, and it also helps your brain to make connections because chances are if they're all on one exam, they're all connected in some way, and you need to be able to jump between. Okay, and it says here that interleaving is helpful because you want your brain to become used to the idea that just knowing how to use a particular problem-solving technique isn't enough. You also need to know when to use it. And that is really important, especially in math, because there's no cues sometimes to cue you in on, oh, this is talking about chapter 1. What did I learn in chapter 1? You have to be able to be like, this is the type of problem where I need to use this method. Tip 7, think of every homework problem in terms of test preparation. So usually what you do is you complete the problem, you check the answer, and you start the next one. But what's really helpful is to take a step in the middle and check your answer and then ask yourself, would I know how to do this problem if I saw it on a test and I didn't know it was from this section? So a way to do this is to maybe take 1 or 2 problem or homework problems from each lecture or each assignment and put them somewhere else where you can jumble them all up, and then when you go to study for the test, you'll have a kind of homework assignment of problems you've seen already, but then just going through and being like, this is how I do this problem, this is how I do this problem, in different orders, so you can kind of help your brain understand which chapter corresponds to which technique, but not necessarily in a sequential order. Okay, tip 8, reading worked examples or rereading problems gives you the illusion that you get it. And so we kind of talked about that, but if you just read through this problem, you're like, oh, that makes sense. You're gonna, take the square root of both sides, -7, it's the variable, got it. Which is, kind of false confidence, because if you saw this on the exam and you didn't see all these steps after it, you might not know how to make that first step. And sometimes with math, that means you can't do the rest of the problem. Okay, tip 9, practice makes permanent. So the more problems you do, the more questions you get right, the more confident you are in your abilities, the more likely you are to retain this and to be able to perform well on the exam. Tip 10, use graphic organizers. So a graphic organizer is a visual display that can be used to organize ideas. So here are some examples. You can kind of read through these on your own if you'd like, but Venn diagrams, mind maps, flow charts, compare and contrast charts, these are all things you can use to help organize if you're having trouble remembering when to use what rule. Just writing a mind map out is helpful to kind of think about what topics you covered for that unit, or Venn diagrams, again, for comparing and contrast. An example of kind of a chart you can make for the definition of a function So you can put all of the characteristics and facts. These are all words. Examples, so write out one equation that's a function. Non-examples, so why isn't this a function? To pass the vertical line test, things like that. And then the definition in the top left corner. So you guys can screenshot this if you'd like to use it, or just draw it out on your paper. And then an example of quadratic function, 3x squared minus 9. What is the domain? What does it look like? What is not a quadratic function? Things like that. And then tip 11, learning how to solve word problems. So word problems come down to annotation and understanding how to pull information out of the problem. Because a lot of times in word problems, they'll either give you too much information, or there's just so many words on the page, it's really hard to understand what's important. So going back to the homes and the Great Lakes, you can remember cubes. Circle the important numbers, underline the question or what you are asked to do, box the important words or phrases, equation development, solve the equation and check your answer. And here's just a quote that says students do worse on word problems when the exact same problem is presented in a mathematical form. So an example. So to repair your automobile, the initial charge is $600 for the parts. In addition to the parts, the mechanic charges $52 per hour for labor. How many hours did it take to repair your automobile if the total of the parts and labor was 834? So circle the important numbers. We have 600, 52, 834. Underline what is being asked. How many hours did it take to repair the automobile? Box the important words or phrases. Initial charge, in addition, per hour, and total of parts and labor. Equation development. So then you have 834 equals 600 plus 52h. And now you can solve and check your answer. So when you get 4.5, when you plug it back in, the total equation should equal 834. And here's just another example of that. If you find this helpful, you can run through this. Tip 12, think back to your mistakes. So it's really important to realize what you mess up on, because a lot of times you're going to see something on an exam and you'll be like, oh, I've done that before. But if you're not keeping track on where you make a mistake, you'll start to second guess yourself. Be like, oh, but did I get that one wrong? Did I solve it the wrong way? So being really vigilant about writing down or making a note of where you usually mess up. If you're prone to making sign errors, if you read too quickly, what you usually do to make a mistake is really important. So here are just some common errors, and you can see some of them have to do with exponents or adding fractions or distribution of a negative sign, things like that. So just be aware of what type of mistakes you usually make and maybe even write them down. And it's also really important, if you can, to get your past exams back, or go visit your professor at office hours and look at your past exams and go over your mistakes and say, okay, why did I get this wrong? Was this like a simple error on my part, or do I not understand the concept? And what can I do to avoid this mistake next time? Okay, tip 13, keep track of what you know. So if you're struggling with a specific unit, you can write down all the topics and then ask yourself how well you understand it. Either I understand it well enough to teach it, I can do it by myself, but sometimes I mess up. I'm just starting to get it, but someone's got to walk me through it and I have no idea what's going on. Something else that can be helpful for math is previewing the textbook, and that's something that I don't think a lot of people do. And it doesn't have to be sitting down, reading the chapter and doing all the practice problems. It can be as simple as talking yourself through it. So looking at the example and being like, okay, first they're going to distribute out this negative sign, and then they're going to isolate the variable by subtracting the integer. And things like that can be super helpful, looking at the objectives, equations, terminology, and theorems. And it kind of just gives you a preview of what's going to come in your lecture. And if you're really lost and you know automatically going in, I really have to pay attention, or I should do some more reading, or I should stay after and talk to my professor. Work a few practice problems, generate some questions. Tip 14, participate in some opportunities to discuss mathematics. This can be study groups, this can be going to office hours with your professor or your TA or your ULA. This can be if you're interested in mathematics as a field, get involved in some sort of club that likes to talk about math, or a club that is discussing new advancements in mathematics. Just basically, the more you talk about it and the more you're open about what you're struggling with, what you like about math, things like that, the better off you're going to be. Exam prep. So if you can, take practice examinations, and with those, you want to start early. Think about what topics will be on the exam, work the practice exam on your own, work any chapter tests or chapter reviews in the textbook, review all the topics covered on the test, and think if you can make your own examples. You don't necessarily have to solve them, but if you have a specific theorem, be like, okay, what is an example of this theorem? What is an example of what is not this theorem? Things like that. And this is a chart you can use when you're reviewing your exams, your past exams, or even your homework problems or your quizzes or any type of assignment where you're doing practice problems. And you can keep track of what type of question it was. Oh, I made a careless mistake, that's okay. I thought I knew this, but I got it wrong. I didn't study it. I didn't understand what the question was asking, or I didn't have time to do it. And you can write down if it's a word problem, a multiple choice, an essay, fill in the blank, true and false, and then it'll kind of give you a hint like, hey, like I'm not so great at true and false math questions. I really need to work this out. Or maybe I need to go ask my professor for some tips on how to understand what she's asking for when she asks us to write an essay question answer. And with that, this is the end of the workshop. Usually I reserve this for questions, but I'm sure you can email the CLC email if you have any questions. Again, my name is Madison. I'm an undergraduate educator, and hopefully we'll be posting more of these workshops while we kind of adjust to this online format, but there'll be more on things such as time management, getting over procrastination, and things like that. Thank you and have a great day.